What's up? I'm Austin. I'm here with Etta and Carlos, and we are on day 5 of week 2, the 10th day of building. Today, we're just going to kind of rehash those not rehash. Hashing is like a verb already. We're going to recover, we're going to cover again the Solidity basics. I think last session, we did hard hat and kind of like how you can write Solidity and then run tests against it. And I think today let's do Solidity, but let's do it in Scaffold-Eth, and we'll use a little bit different tool, and that tool is going to help you have a lot more insights and give you the ability to tinker with your contract. So I feel like we should start with just like a simple installation of Scaffold-Eth, since it is kind of a pain in the butt to install. It takes like 10 minutes. So maybe we could kick it over to you, Etta, and you could show your screen, and we could start from like complete scratch, pull up a terminal, go to the repo, start cloning it, start the install. That's going to take time. And then I'll steal the screen back and show my version that's like already installed and ready to go. And we can kind of tinker while the installation is going. All right, let me kick it over to you. Yeah, you got it. You got it. Yeah. Awesome. We just basically
Awesome.
Googled Scaffold-Eth, right?
Yeah, just Google Scaffold-Eth. It's the first repo that comes up. And let me pull up my terminal over here. But before that, so yeah, you also have the README over here on how to do this. But let me just go over here, get the repo. It's gonna go to my machine. I'm just gonna go to the desktop, and then let's make sure. I'm gonna call it Zoom because that's what I've been calling everything. So this is going to take a few moments to get all set up. But yeah, basically just Google Scaffold-Eth, go to the first website that pops up. It's going to be GitHub, and then clone the repo down.
Awesome. Okay, so we're cloning it down. I might even steal the screen back because I don't even know how long that's going to take.
Yeah, it takes a few moments.
Yeah, it does. Okay, so here we go. Let's see. Let me pull this over here, and we got the Sanford token we might mess with a little bit. But once you get Scaffold-Eth all the way installed, you have, I did the scaffold-eth.io. So you clone it down, and then you're going to do this step next, but I've already done this. And then you yarn chain, and that brings up your hard hat node. So just like hard hat, like we had before, you'll have a hard hat node with Scaffold-Eth, and then you have a front end. This was the yarn start. Okay. And let's do this all again on your machine too, but I kind of want to speed run through it. And then you do a yarn deploy, and that's going to deploy your contract. This time it's probably going to say it's reusing your contract. This is the first little, you need to do a yarn deploy -- reset if you want to force that contract to go. Okay, so then we've got our contract here. And oh man, I've got this Zoom bar. Let me get out of here. There we go. And then here's the front end. So this is that same mode that we were in, where we were kind of making a small change in Solidity and then compiling it and then making sure our tests run. You get into a similar iteration loop with Scaffold-Eth, but what you're doing is you're basically tinkering with your Solidity and then yarn deploying, and then you'll get your contract over here in the front end, and you'll kind of tinker with it. See how we got a new contract address there? Let's do it again. And we should see a new contract. So this is a little bit different than the hard hat version, where we were just like editing Solidity and then we were running our tests or writing our tests to make sure it works. This is a little bit more like visceral and upfront. You kind of can make a small change. Let's just add some more exclamation points just to make just a simple string change. You deploy, and then you should see it show up in your front end as it deploys and hot reloads. So this is just a different iteration loop that you can get in, but very, very powerful and very quick to be able to edit some Solidity. But let's see. So you did a git clone. I suppose you're probably about to run your yarn install, or did you already run that, Etta?
I'm on 72%.
Okay,
so we're
cool.
still waiting for the
okay, I'll just steal the screen and hold it here. Yeah. Okay. So let's just edit some Solidity, right? Let's get into this mode of editing Solidity. So let's see. We talked about primitives and data types and globals, right? So we talked about globals, Solidity. Let's have those up, right? You'll want to have your globally available units. Let's even just like pick one out real quick. Let's look at the block.timestamp, okay? And let's just create over here, let's just create a read function real quick. And we'll call it timey. And it's going to be public, and it's going to returns a uint 256, right? And let's just return the block.timestamp. So anytime you're just like dinking around with these globals and you want to know how they work, let's go ahead and deploy some new function that has some new timey, and let's see if it adds it over here. There we go. And we can call this, oh, wait. That should be a read function. Public views, come on. Did it even, it gave us a warning even. Yep, there we go. This is the kind of iteration. Public view, is that right? Why didn't it turn view into, maybe I have an old, there we go. And now we've got our time. And as we kind of make transactions, that time should change. Or if I deploy again, we get a new timestamp. Okay, so now we've got our global units. We've got a way to kind of view those global units right away, a nice way to tinker. The next thing is Solidity by example, right? And we talked through, I think, primitives, right? So we talked about, you know, you can bring in a bool. Let's throw one in here. Okay, and you could bring in a uint 256, right? Let's do that, right? Oops. Okay, and you could bring in an address, right? All of these primitives and data types, we're just kind of pasting into our contract. And then I'm going to do a yarn deploy, and then I'm going to go look at it on the front end and tinker with it and make sure it does what I think it's going to do. There we go. So our bool is true. Let's maybe even build a function real quick called toggle that does something like boo equals not boo. All right, just simple functions. Let's see if we can flip that bit. Let's see what it does. So now we should get some what did we call it? Toggle. Okay, we should get some toggle function over here. So now boo is true, and if I call toggle, oh, it's not gonna, because I don't have gas. We need to explain wallets real quick, but I'll get to that. Grab some funds from the faucet, and then when I hit toggle, boo toggles, right? We're toggling our boolean. There we go. Okay, let's get, I'm going to dump that stuff out of there. Just kind of getting it shown off how you can get into this habit of throwing some Solidity in here and tinkering with it over here on the front end. I'm going to delete, is our uint there? Let's just pull out all this stuff, get back to our simple contract. Okay, wallets, right? We did something really weird with wallets there. I feel like that's worth explaining with Scaffold-Eth. If you open up a new incognito window, look up in the top right here. We're going to have a new address. There we go. There's that red address. Now, if I close that, see how he's kind of like this red dude? You can grab some funds from the faucet for the red dude. Let me close that and open up another one. We should have a new account. There we go. Now it's like green dude, right? One more time, localhost. So Scaffold-Eth creates burner wallets for you on the fly, and it makes editing and tinkering with your contract a lot easier. Let's go ahead and redeploy our contract. Okay, so let's see. So we're able to put in globals. Well, we're able to bring in some primitives and tinker with them. Let's see. We've got burner wallets. We'll bring in the burner wallet in a little bit. What I'm thinking is we should just probably write a small contract that does some kind of like using these primitives. Maybe we should even explain the contract that comes with Scaffold-Eth out of the box and then do some Solidity tinkering. Does that sound good? Okay, so we've got, it looks like there's a string here. Is that, hopefully that's very readable. This is very much like the greeter contract. There's a famous greeter contract where they you have this greeting, or you have this string, and then you have some function to set that string. Something really interesting here is a nice little console log here. Whenever someone calls set purpose, it does a console log over in the hard hat node. Let's go do that real quick just to see it. So I'm going to need to call set purpose with some new purpose. So I'll say hello world here. And I have some money for gas. And you'll notice with that burner wallet, there's no MetaMask pop-up here. There's no, it just fires the transaction off, which is really nice. And then over here in the console log, we see sure enough, we set the purpose to hello world. Okay, so we're in the mode, right? We've downloaded Scaffold-Eth. We know what our globals are. We know what our primitives are. It's time to start tinkering a little bit. Let's do what we did last time. I think we brought in like a little bit of an ownership pattern, right? We had some boss. Let's see. So we'll make an address public boss, and we'll set that equal to our front end address. I'll just copy and paste that in, and let's ship it. Okay. And we're just going to do like a couple lines of Solidity and ship it over and over and over again. We should see it. There we go. So now we see our boss, right? Over in the hard hat version, we kind of had a test that we would run, right? We would set the boss, and then we would make sure that the test made sure that the boss was set. Here, we're just kind of doing it visually, right? We kind of like, we've got our boss, we've got it set. That looks good. Then maybe we require that you have to be the boss to set this. Right, so we're going to say msg.sender. That's that first global that we learned. It's whoever's making that message, or whoever that it's coming from. Once we get to contract, this will be a little different. Equals boss, or we say not the boss. Okay, and deploy it. Right, so just small changes to your Solidity. Test your assumptions, try it out. Now we should only be able to set the purpose as the boss. So this should work. Okay, but then how do we test the counter, right? In the last week, we had to basically write a test where we had a second account try it. Let's just try it with the second account here in just an incognito window, right? So we've kind of got green guy over here. Oh, this guy's kind of green too. Let's get a different one. Get an account so we can have a good bad guy. Yellow guy. Okay, it's kind of still green. Come on. All right, last try. Whichever one we get here, we're going with. Okay, so this is bad guy, kind of yellow red guy, and then we've got green guy over here. Grab some funds from the faucet, and if we try to set the purpose, trying this, hopefully we get a message that we're not the boss. Okay, so instead of writing a test, which a test is really nice because you can have it automated, and any little change you make, you could run your entire test suite. But when you're just getting started and you're tinkering with Solidity and you're trying to figure it out, this is really handy. We can write a small require statement, and then just using the front end, we can kind of quickly test if that require statement is working. And it seems to be working so far. What's the next concept we should go after? I feel like I'm talking a lot. What's the next thing we attacked yesterday or last session?
I was thinking that maybe we could take a look at the deploy script that we are using for this Scaffold-Eth deploy, and maybe like putting like some params into the constructor function, so we can like send like some some if or some maybe that the owner, like the boss address, right? Like we can send that into the constructor.
Yes. There we go. That's a good call. Okay, so we're gonna have some address. I'm even gonna make it immutable. Is it public immutable? So it's only going to get set once, and we'll call it boss. Okay, and then we'll set the boss to the starting boss, and it should never change again, right? Quick little thing. Let's see if that worked. Quick little interaction. Let's see if this deploys. Oh no, it did not. What did I do wrong? Let's see. Oh, arguments, right? Yes. It needs an argument passed in, right? So like you said, we go here. We're going to go to the deploy script in Scaffold-Eth, and this is already commented out for you. There's a lot of scaffolding in Scaffold-Eth, right? This is just another little piece of scaffolding here where it's like almost ready to go for you. What do we need to do? We need to put in this dude's address probably. Okay. And let's try that. There we go. Okay. And one other thing I want to do, let's do another address, and let's call this the deployer. And let's set the deployer equal to the msg.sender. There we go. So we're going to deploy our contract. We're going to pass in some boss. And then we're also going to have some other address that we track that's called the deployer. That's going to be whoever deploys the contract. So there's kind of two addresses. There's the boss address and then kind of whoever deploys. And we'll see that these are slightly different addresses. The deployer is going to be that first hard hat address. We've talked about this probably a couple times before, but as hard hat spins up a new chain, it has a whole bunch of addresses attached to it. And so who's deploying our account is that's the F39, right?
Yeah,
We've
our
seen old
friend already,
F39
yes.
before. Yes. And another place you'll find F39 is down here in the faucet. If you open this up, this is basically F39, totally loaded with 10,000 ETH. And this is a good time to kind of show off wallets in Scaffold-Eth. But if I copy this guy's address and I open up the faucet wallet, look what I can do. Kind of right here in the UI, I can give myself a whole bunch of money. There we go. So now I have enough money to do lots of stuff. Instead of kind of sending them around or dealing with accounts here, you don't want to be copy pasting private keys. You want to generate a nice burner address and fill it up with the money you need, and then go interact with your contract. Okay, so we do have construction arguments now, right? And we are passing in some starting boss, and that boss is immutable. It only changes once and gets set here, but we've got our boss, we've got our deployer. Only our boss can set this. Okay, this is a good time. This is usually where sorry, I'm like stealing all the time here. You guys jump in if I need to. If you need to, one thing I like to do is I like to do a payable here instead. So I make this payable. I turn it, right now it's basically like an attestation smart contract. One person can get in and change something, right? One person can set the purpose. We know that smart contracts are more like these vending machines, always on, permissionless programs that people can access and run. So let's make this a little bit more decentralized, and let's say message.value needs to be greater than or equal to some amount of ether, right? And then we'll say not enough. So we just made a small change to our contract that instead of one boss gets to set things, now anyone can get in here as long as they pay a little bit of value. And sure enough, our front end auto adapts to that, right? It notices that the set purpose now needs to take in some transaction value. And so let's set that to hello world again. And if I put in 0 transaction value, it's going to say not enough, right? What we need to put in is 0.001. And then here's another little trick from Scaffold-Eth. You need to take that times 10 to the 18, right? We need to take it to way. And Scaffold-Eth is going to force the developer to do this. If you're a builder, I want you to be forced to say, well, it's 0.001 times 10 to the 18. I want you to be thinking about that. So, but when you build your final app with Scaffold-Eth, obviously you'll do a little different, and you'll have it so your front end handles that kind of stuff. But here we go. Hello world. Let's put in 0.001. Let's take it times 10 to the 18 and let's pay. There we go. So we were able to test this line and make sure you have to pay. And now we see that there's a contract here, and the contract has value, right? So we're able to set this up. Let's maybe even do a UNT 256 public price, okay? And set that equal to 0.001 ether. And then we'll put that in here. All right, so we just have a price function now, and anybody can see in the contract what the price is. Let's deploy that. Just making small little iterations, just showing you at home that you can paint some happy little trees here. Like you can build things very quickly. You can try things out and you can see them in the front end. Let's add one little line of code. Here's where we're going to get weird. We're going to get weird and financial mechanism-y. We're going to say, once someone sets the purpose, the price is going to go up by 1% or something like that, right? Notice how we don't have decimals here. Let's see if this works. One little change to the smart contract, and now we have a price function that after I say hello world the first time and hit go, the price goes up. See that? Now the price is at 101. Hey, and I hit send again, and the price goes up again, right? So with the single line of code, our vending machine now accepts money only on a price curve, right? Just random little things we can add in here that can make this really interesting. Okay, what things did we cover yesterday? I'd like to dive in and cover them like quickly with Scaffold-Eth. What are some more topics that we covered yesterday?
I think like also it's nice to have like Solidity by example on the side.
Yes, where is it?
Like
yeah.
Search for it, like what can I use? It really helps out.
Awesome. Yeah, so we did primitives and data types, variables, constants, immutable. ether to way is kind of like happening a little bit right here, right? We saw this where we typed in 0.001 ether and we took it two-way. That's another big gotcha of Solidity. You'll have to kind of learn that. Gas, if else, looping. I'm assuming you're like a programmer once you've landed here. So this stuff you should be able to pick up almost instantly. Mapping, right? Let's get to the mapping. Let's build a token, right? Okay. So we've got our deployer, our boss. I'm just going to clean a lot of this stuff out of here. Let's see.
Maybe we can set like the count. I mean, right now only like the boss can set. Well, you commented the line, so anyone can set the price, right? So maybe we can store the count of the people that has set like the purpose, so we can have like a mapping with address and account. Like, so every time that you set a new purpose, you can like increment that count for that sender.
I'm gonna make it a U at 8 too for some reason. It only goes to 255. So there's like a your count, right? And basically every time anybody sets the purpose, we do your count for the msg.sender ++, something like that. Pretty simple, straightforward code. Let's see, our price isn't going up anymore. We've taken out our price curve. Let's see if this works. So just right now, all we're doing is we're learning how a mapping works, right? We're saying, okay, a mapping is just a mapping of some data type to another. For any given address, there's going to be some uint. I think we already talked about this, but the downfall of a mapping is that you can't iterate through it, right? So if we want to keep track of a bunch of balances, but we don't have to iterate through everyone's balance, a mapping is a great way to do that. What we're showing off here is that in Scaffold-Eth, this mapping is going to show up right away for you, right? Let's see. Oh, I forgot to make it public. Boo. Classic. When you add something here and it doesn't show up here right away, it's that public, and you got to remember to set it. Okay, now we have a your count variable down here, right? And if I check my count for green guy, it's 0. Okay. Then if I set the purpose, hello, I can't spell world today. Hello world, and we pay some money, and then we do hey, and we do it again, and then we go check our count. Get out of here. We check our count. Now it's at 2, right? And then if we bring in another bad guy, they go to localhost. I like how all the incognitos are bad guys. Everyone's a bad guy on the blockchain. That's what's cool about it. They're all adversarial parties, and it still works, right? Okay, hello. And this dude pays the 0.001 ETH. There we go. And let's check his count. Red guy's count should be 1. Boom, red guy's count is 1. Okay. So that's just showing how mapping can work, right? We're going to Solidity by example. We're picking up these ideas, these concepts, and we're playing with them. Let's do a token real quick. I'm just going to clear out. Yep, go ahead.
Just wanted to add, because I saw events over there. So I think it's nice to show like how the events reflect to the app home page as well. Like we're like looking to the smart contract, but since it's over there, might be worth like just showing the
Okay, before we build a token, let's make sure this is deployed. Okay, so we have let's forget our mapping for a second. let's forget this mapping, and let's just think about do we even need the deployer? Let's clean this out just so we have a lot less stuff here. There we go. We don't even need this stuff really. Okay, so from first principles here, we have a constructor that sets some boss, and the boss doesn't even matter right now, does it? Nope. The boss we're not requiring anything. Maybe there could be a withdraw function and only the boss could withdraw. But what we're doing here is we're allowing anyone to set the purpose. They pay a little bit of money when they set the purpose, and this event is emitted, right? We talked about storage and how on-chain storage is very expensive, but events can be used to kind of like power your front end. So let's see how this event works. It should emit a set purpose every time someone sets the purpose. Let's go tinker with that. So let's go to the front end. Let's reload this. And let's set the purpose to hello world and pay a little bit and hit send. Okay, that should have triggered an event. And within Scaffold-Eth, you can use an event listener, and I think it's right down here. Yep, there it is, right there. So over in our example UI, which we can see here if you wanted to really look through the front end side, there's a front end that's created for you with Scaffold-Eth. And what we're doing here is we're just showing you how you can, there's an input field here. And then when it changes, we have some state variable that's the purpose and a set new purpose. And then we have this button called set purpose. And what it does is it calls the set purpose function on your contract. So it's a nice little UI scaffolding that shows you how to build, shows you how to build a UI that will talk to your contract. And so if I say hello world here, and my hello worlds, hopefully this works. Oh, not enough. See, this isn't paying money. Okay. Hold on. Let's set it. Let's set it so it's not payable. No money going in. Very stock, a stock set purpose. So our example UI works. Okay. Now over in the example UI, let's try a hello world. So there are no events, right? So our events are empty. Let's do hello world. This time we're not paying anything. We should just be able to set purpose, and let's see if those events show up here. There it is, hello world. Then if we do hey, and we set the purpose, we see another event, right? So to go full circle on this, basically we're emitting the set purpose, and then the front end has an event listener. In the example UI that shows you how to handle your events. Nice little React component that shows you how to handle those events and display them. Okay, awesome. So let's see, we did events. We did, before we do like contract to contract interaction, I really want to do a quick little token with a mapping. Just build, it's the same thing we built yesterday or the other day. I'm gonna just, let's see, we got a boss. Do we even need a boss? We don't even need a boss right now. Let's take that out of this. Let's clean this down to a very simple contract. We don't even really need the purpose. Here, yeah, let's look at this. There's nothing left here, right? Nothing. It's just a constructor. Why is the constructor payable? Does it need to be? All right, let's make sure this deploys. Basically an empty contract. It probably won't even show us anything. Yeah, it's nothing, right? Okay, so let's make that token again. Let's start with that mapping. So we had a mapping from an address to a uint 256. We need to make it public, and we're going to call it balance. Balances, I don't know, balances, right? This is basically all you need to create a token. You need to have some list of balances, and then maybe when we deploy our contract, we'll have our address get 100. And let's deploy it. Let's see if it works, right? We're just tinkering with Solidity. We're seeing it in the front end. We're poking at it. We're making sure it does what it needs to do. Let's see what happens when we check our balance. Awesome. And if I like connect my MetaMask or something and check its balance, oh, oh man, was that it? Oh man.
Yeah, Carlos and I had to come in there.
yeah. Come on, there we go. Okay, and now we're just waiting on MetaMask. Still waiting on MetaMask. All I want to do is just get an account. Okay, there we go. Yep. Oh, it has this. This is another thing about Scaffold-Eth is it notices what network you're on and switches you with a nice little button. Lots of little nice things with Scaffold-Eth that like I just needed for hackathon after hackathon, and I built it into this. Okay, so now if I check this guy's address after all that, it should be 0, right? Okay, log out. That was not worth the wait. Okay, so we're keeping track of balances. We're setting someone's balance at deploy, but really we need one other function to make this into a token, right? If we want to make a digital currency, we need some kind of transfer function. And we'll have our address 2 and our uint 256 amount. We'll make it public. Okay, and then what do? We talked about this last time. Usually we would want to have some kind of require statement here to make sure that the to address has the amount. But since we're using Solidity 8, we don't need safe math. It's built in. So basically we do something like this. We say balances of the msg.sender minus equals whatever this amount is, and balances of the to address plus equals the amount, right? And if we were writing this in hard hat, we'd build a bunch of we'd build a bunch of tests to make sure that I send it and my money goes correctly and I can't send money I don't have. But with Scaffold-Eth, we're just kind of like trying things out here. We don't need to build any formal tests yet. We're just kind of tinkering with Solidity and kind of learning the basics and the ropes. And this is what you're presented with. You've got balances, you've got transfer. If I check my balance, I have 100. Okay, let's make another incognito address. All right, let's bring up this dude over here. We got blue guys, we got green guy and blue guy. Blue guy can grab some funds from the faucet. If we check blue guy's balance, he's at 0. So let's transfer 2, right? We're transferring 2 blue guy, and let's transfer 10. And by the way, this is 10 way. This, by the way, this is 10 way. We're doing all of this here as 100. Whenever you write a number in here, it's just way, right? That's the same thing as way. The smallest amount of ETH you can have. If I put ether, this is actually 100 times 10 to the 18 and a much bigger number. Right now, we're just talking in way. We're just moving around a little bit of way. So I'm going to transfer 10 way, right? Then if we check this dude's balance, it should be 90. And if we go check this dude's balance, it should be 10, right? So we're able to create a currency by just having balances. And then we give some initial mint to someone, and then we create a transfer function that allows people to move it if they have it. And if they don't have it, let's try that. So let's just grab some random address and try to send 999, and it's going to fail. It's going to give us an overflow, right? What it does is it's trying to subtract, and it's getting an overflow there. So this is yet another way to tinker with Solidity and build a little token like we did last time, but in a way where you're using Scaffold-Eth, and you can kind of quickly spin up these wallets and these front ends that can kind of help you tinker and learn. So I think eventually we're going to move to contract interaction, but maybe we want to fill in some more details here. Maybe we could even go back to Edda, and we could take last week's contract and kind of paste it in, and you could show us how that looks on your Scaffold-Eth. How does that sound? Oh, I think you might be muted. I'm going to go ahead and stop sharing, hand the screen off to you. I've been blabbering too long. It's your turn. Let's do Scaffold-Eth on your side.
Okay, I'm going to share my screen. Okay, so all I did was a yarn install. So basically just went to the folder and did a yarn install because it takes a while, so not to wait to see it install. But yeah, I have it open on my IDE as well. Didn't like do anything, just open the package. So you can see a new Scaffold-Eth package. I'm gonna go down to my contract over here. We can actually like run it first as well. Oops, this is like verifying something. But maybe it would be good to like just start by deploying the contract, like setting up the chain, right? I didn't do all that, but just like quickly run through it.
Yep. There we go. So yarn chain is like the first command. So you did a clone, you did an install, and now it's yarn chain, and that brings up your hard hat node.
Yeah, and then a yarn, you can directly do a yarn start as well to like get the front end up.
That'll start your front end.
Yeah, so it's supposed to pop up. Okay, I have it here.
Like if you are curious about like these commands, like yarn commands, you can also check the package.json file, and you can see like, for example, like the yarn deploy, you will see that the command that is actually executing is like hard hat deploy, like the things that we did the other day.
Yep, and yarn is like a fancy NPM, right? Yes. The reason why we're using yarn is because it allows us to do workspaces, and allows us to bring in like 3 different projects at once. We have create React app, but we also have hard hat coming in, and yarn sets that all up for us. But yeah, you can just look in the package.json to see like what commands it's actually running underneath the abstraction. Okay, so we've yarn installed, we've yarn chain to bring up our local node, we've yarn start to create a front end, and then did you do the yarn deploy?
Yeah,
I yarn
just
deploy
did a yarn
is the third
deploy
one.
over
Perfect.
here.
And then we deployed our contract. Yeah. Awesome. So we have our stock contract, we have our front end. Here it is.
Yeah, and you can see like the burner wallet, everything is up and ready. So just what Austin was showing. Yeah, just pull it. You have all the tabs. Before you do like yarn deploy, you won't have this. You need to deploy the contract to have it show up. But yeah, so like, shall we go to yesterday's
Yeah, let's
script
just
to, like,
set the
get it up?
purpose real quick. Let's make sure the wallets are working.
Yeah.
Let's make sure like we can make a small change to the contract and that works. Just a little, like, just double checking things are going. See if you can set the purpose, I would say, would be the first thing to test.
Okay, sure. We can just use the UI.
Yeah, we can
you can
use the
also do it
example
from
UI.
the
Yep.
debug.
And it's going to tell us we need some
Oops.
funds from the faucet.
Yeah. So I'm just gonna use this over here.
Yep, 3 different
and
ways to
some-
do it. You could hit the little blue button, you could paste the address in and hit faucet, or you could bring up the wallet. And now we showed all 3 in this run. There we go.
Yeah,
Now you
it
have
gives
tons of funds
little
from the
ETH,
faucet.
so I'm gonna get more.
You
yeah.
gotta do that. Yeah, it's more gratifying. Yeah. Okay, and we set the purpose, right? Did it go? There we go. We see that we see the event. We see that it's tracking it, the example. Yep. Awesome. Okay. So this is the stock Scaffold-Eth setup. This should be, if you have this set up locally, you should now have the ability to like really iterate on Solidity. You should be able to grab some Solidity by example and paste it in. Let's go grab our old contract, our Sanford token, and let's paste in some of that stuff and let's see it in the UI. Let's see how the UI auto adapts to that new contract. I suppose you could just grab the whole guts of the contract and try pasting it into your contract and see what happens.
Yeah, so that's the one of the days one of the days contracts, right? Not sure which day it was.
It was oh here. I'll send it in chat. It's this one right here.
Awesome. So yeah, just going to week 2 and I can actually just pull this up over here as well. So you can see like all the contract. I'm not going to get just going to get the inside of it.
Yep.
We can just copy this.
I think you might have one extra brace there, but we'll be good. Brace yourself.
Okay, then I'll just delete one.
We'll figure it out. Yeah, we'll figure it out. Perfect. There we go. So this is an example. You just find some contract on the internet. You can randomly just like copy and paste that thing into your contract and then deploy. Does it have constructor arguments? Nope. This should compile and deploy, right? Like without any, let's see what happens. There's only one way to find out.
I believe we need to do reset as well.
Anytime the contract changes, you don't need to do the reset. It'll notice that there's a difference. Okay, so it gave us one little tiny warning, but we will ignore that for now. We don't need that. But our contract just totally deployed. And if we go to Scaffold-Eth and we look at the debug contracts tab, now we have all of these cool things from that original contract. We have the boss, which is the deployer. We have some buy, we have some create, we have some send. I don't even remember what this contract does. This was you, wasn't it, Carlos?
Yeah. But I mean, it's amazing to see, because like we have been like for 20 minutes, like tinkering with Solidity, and it was like super fast. Like if we try to do like the same thing, like using hard hat, like yesterday, it's way slower to do that. And I think like we talk about the workflow, which is for me perfect, which is like going with Scaffold-Eth first, at least like tinker like the first, when you're writing from scratch your contract and tinker a lot. And then when you have like kind of like the final version, maybe you can start like thinking about like making tests. And because if you want to make quick changes, like the hard hat way is like the hard way, right? So yeah. So I just like want people to appreciate how fast it's like tinkering this way, right? Like because you can see, like super fast. You make a change, deploy in 2 seconds. You just get like instant feedback from the UI, which is great.
And hard hat's like a wonderful tool. Like we love some hard hat, but basically writing your smart contract in the form of like test-driven development, right? If you write the test first and then write the smart contract, you really know what you're doing. You really understand all of Solidity and you know exactly what that Solidity needs to look like and you're writing it for the test. Most of the time, you're still learning and you're still trying to like, do I want to keep this in a struct in an array? Do I want to keep this in a set of mappings? So Scaffold-Eth allows you to kind of like tinker with things first and figure it out. And like you said, Carlos, build the test after you have the contract kind of working the way you need it to, but assume that you can come into this kind of like pretty blind and you can try this out and you can learn things. So what do we have here? We've got a total supply. We've got a total. Oh yeah, we had this total created, and we paid attention to, yes, there's a creation price. We kept a struct of votes and an array of all the votes. We have the boss getting set. Oh, we have a modifier, so only the boss can set it. Then we have a create that increases the, oh, make sure the total supply isn't. Oh, that's what it was. It was a supply cap. We created a cap on the supply, and we only let you create a certain amount. We let you send it around. What does buy do? Lets you pay. Oh yeah, message.value equals creation price. So you pay a little bit and you pay one and get one.
I think we have like the create only for the boss. So
okay,
you can, yeah, like
that's what
you can
it
be
was.
like for free and then buy just for like the public. So they need to send some ETH along the transaction.
Okay, so the first thing I'm seeing here is the boss is the deployer account. And a lot of times we're going to want to have us as the boss. So this goes back to our deploy script, and it shows something really cool with Scaffold-Eth. What we need to do is set it up so it transfers the ownership, right? Which leads to maybe we should do inheritance and have an ownership pattern, right? Okay, so right now it shows the boss, and the boss is the deployer, and we have our own modifier. Okay. Yeah. I think what we want to do is inherit OpenZepplin's ownership pattern here first, right? Yep. I think we should. Okay, so man, it's kind of a tough transition to make because we have so much other stuff in the contract. Like the best way to show this off is just to have just the ownership stuff that we've written, and then carve that out and inherit it, and then you see that like, oh, we didn't write the ownership stuff, we've inherited it, but there's a lot here. So I don't know, it might be extra complicated, but I say we work through it. Do you have
maybe we can just like test like the only boss modifier. I think the create function is using it, right?
The problem is that the boss is that F9 account. So we need to set us as the boss.
But we are using Scaffold-Eth, right? So we can like iterate like super quick. So maybe we can just like paste, like copy the front end address and just like equal to that address, right? Let's
do that. So let's copy that address and let's go to the smart contract. Where is it setting that boss? It's setting the boss in the constructor, right? Yes. So instead of using msg.sender there on line 29, let's just paste our address in. Yes. Very heavy-handedly. Boom. Now we're the boss, right? Now go ahead and deploy that, and let's see if we're the boss. And this is exactly right. This is what Scaffold-Eth is all about. Quick iterations, like make big breaking changes and try things and see what happens. So look at that. Now we're the boss, right? There we go. It's deployed and we're the boss. So now let's do that. It was create, right?
It was create. So you can create like 10 tokens.
And let's see what happens.
We can create more.
Okay. 108. We created 108.
We can do it more than 10.
Okay, now we need a bad guy, right? So we need to maybe.
You can also like check the balance, right? You can on the balance on top, you can like check your address there and see if we have like the 100.
Nice. We have 108. So okay, now we need to have a bad guy. Can a bad guy create? And we should see that a bad guy can't create, right? Instead of writing a test and having the test say it passed and having this weird, like, did it pass? Do I really understand what's going on here? You can see it visually and make sure you understand what's going on. Okay, so the first one, it's saying, sorry, not the boss, but also you don't have any gas. It's nice to like make sure you have gas. Yeah, now try it again. It's going to say not the boss again, but it's always just a good practice to do that. Yeah. Okay, so without writing a complicated test, we basically just created another user and tried it, and we saw that it fails. So now it's set up so I think only the boss can do the create, and that's great, but we've written our own custom logic. We've created this custom boss. We've created the require statement. Maybe we did it wrong, right? So the key here is that a lot of other people in the space have written some great contracts for us. And whenever we can inherit someone else's contract, unless we're like, really low level, we understand what we're doing here. And arguably with an ownership pattern, you have to keep track of one address and create one modifier. So in this case, maybe the ownership pattern could be something you write yourself, but let's just inherit OpenZepplin's ownership pattern, and let's carve out anything where we had to make our own owner. Instead of us keeping track of an owner and setting it, let's inherit the smart contract from OpenZepplin that keeps track of an owner, and let's use their ownership pattern. So on line 5, we'll uncomment that, right? We'll import OpenZepplin's ownable. Then on line 8, we need to inherit it. So we'll say your contract, and we'll say is ownable. Yep.
And maybe we can also take a quick look into the contract, right? Like into the ownable contract, so we can see what we are inheriting.
And the way, how do you do that? Do you usually just like Google OpenZepplin GitHub or something like that?
In my IDE, if you click line 5, it goes to the contract, but I'm not sure if VS Code is going to work. I say like control and click into ownable. No, okay. So
something happened.
You go to definition. Yeah.
Oh, that's good enough, right?
Yes,
that's good enough. That's so this is the contract we're inheriting, right?
Yeah.
Cool. And so, it itself inherits some contract called context, but let's ignore that. So basically, what do we see here? We see that there is a constructor that transfers the ownership to the message sender, right? And then there is an owner function that gives us whoever the owner is. And then there's a modifier, just like our modifier, that says only owner, and make sure that the owner is the msg.sender. And if it is, it does the underscore and runs everything. And then there's a couple other helper functions: renounce ownership, transfer ownership, and transfer ownership. Whoa, what's the difference? One is internal and one is...
Yeah, I think.
This is classic, like OpenZepplin. They do a little bit of extra stuff and burn a little bit of extra gas every time. They're making sure you don't transfer the ownership to the 0 address. They have a separate function called renounce ownership that sends to the 0 address. Whatever. But the cool thing is, lots and lots of people have had their eyes on this contract. And if there was something wrong, we would know about it already. Now, when you inherit stuff, you still need to have your whole system audited, but understand that these contracts are pretty solid on their own. So let's inherit it. Go ahead.
We have like the same thing that we have before, right? Like the only boss modifier, plus some other stuff that they added, like the transfer ownership. And also, like you say, like a lot of people have tested and put their eyes into the contract. So there are probably no errors or no bugs in those contracts. And if you do it yourself, you probably have like some bugs at some point in your Solidity career, for sure. So
totally,
whenever you can like go for inheriting stuff that is already done for you.
Unless your transmission's 11 and you think all of the OpenZepplin stuff is garbage and waste gas. Once you get like super technical and super into the weeds, you may have other, but as you get started, this is absolutely the best way to go. Inherit stuff from OpenZepplin. Things like even the ERC20 standard. If you're trying to make an NFT, basically, if you're trying to make an NFT, you inherit OpenZepplin's NFT and you set the name of it and you set up how the mint function works, and that's it. Everything else is handled for you. So lots of things like access control, lots of helpers like cryptographic helpers and EC recover stuff, tons of different things that you want to get into, you can grab from the OpenZepplin stuff. And you just Google OpenZepplin GitHub, you'll see all their cool contracts. Okay, so back to our contract. It is, I think we set it so it is ownable. There we go. Yep. We have is ownable. And then we probably don't need to track the boss anymore, right? So we can delete line 17.
And also line 27, right?
Yep. We don't need the line for the constructor anymore because it's doing it in the constructor from the one that we inherit. We don't need the modifier anymore. And now we can, on line 30, we can change it to only owner, right? Which is the modifier that comes from the library. So there we go. We stripped out a handful of things from our own contract and we just inherit it from another contract that's safer. Hopefully that's clear, but let's run it and see if it works. Let's see if it does the right thing.
I think there is another only boss in there. So
ooh, is there? It'll yell at us right here.
Yeah, we'll but let's see.
Yep. Yeah. 54. Yep.
Yeah.
What was it? Maybe a withdraw function. Yep. That's it. Yep. Awesome. There we go. Oh, and boss.call. Ooh, what are we gonna
But
have to
I
do? Is it
think-
underscore owner or something like that?
But I'm not sure if that's private. I don't know if that variable is. I mean, we'll need to check the ownable. Right?
Yeah.
Like,
If we go to the Ownable.sol, we can
Yeah.
see how
You're
we get the
right.
owner.
so I guess we
Yep.
need to call.
There's an
the
owner
function.
there, right?
Yeah.
Yep. So we'll just call the owner function and it should return the address.
Yes.
So do we do owner and then open parentheses, close parentheses, dot call?
I think
So
so.
I think
yeah.
we replace boss with owner parentheses. Yeah, like that. That's what I was thinking too.
No.
It's not.
And maybe
Well,
without
maybe.
the parentheses. I don't know.
No, it's happy. It's
okay.
happy.
Yeah.
Let's try. Let's try it.
It doesn't like the fact that we're not using that data, but that's fine.
Yeah.
Let's see if this works. Yeah. Yeah. All right.
Nice.
All right. So now let's make sure that only the owner can call that create function again.
But the thing is that now we are not the owner, right?
Oh, yeah. Look who the owner is.
Because if you check like the constructor of the ownable contract, you will see that it sets the deployer as the first owner.
Yep. And we can't heavy-handedly paste our address into this one. We're going to have to do it right?
Yes.
We're going to have to transfer ownership, right?
Yeah.
Okay, cool. So if we go back to the Scaffold-Eth real quick, you'll see that the transfer ownership and the renounce ownership have showed up here, right? We see that we could technically transfer the ownership. And if we look at the owner, it's our friend F39, right? So the deployer owns the account and we need a way for the deployer to hand the account off to us. What we need is the deployer to call transfer ownership to us. And the place we do that is in the debug or in the deploy script.
Yeah, we could also do like if
Yep.
you want, like we could like import the private key of the F39 because it's that's like really ugly maybe, but like you can import that into MetaMask, like connect with that account, and then you could call the transfer ownership from here. But usually,
and a lot of people do that. A
Yeah.
lot of coders right away, they think that's a great idea and it works, right? And then you have this nice account in your MetaMask that has all the local money and it's all connected. But it's a bad practice to be copy pasting those private keys into your MetaMask like that. You need to definitely have a debug MetaMask or a developer MetaMask if you're going to do that. It's as soon as you learn how private keys work and how the systems work, like everyone does that. Everyone starts to copy and paste private keys around. It's a bad idea. Like you'll get yourself into a lot of trouble with that. Let's technically you can do that. You could easily go get the private key from Hardhat. You could paste it into MetaMask as a new account, but let's not do that. Let's do a transfer ownership instead. Let's have a nice burner account. And when it deploys, let's have it transfer. So we need to go to our deploy script. It's not that script. This is the old one, right? It'll tell us, yep, that's the one. Yep. And if we get in here, we see where those arguments were. This is the same thing I was doing. I uncommented line 23 and I added some arguments. But like that scaffolding, there's lots of scaffolding here. See these comments that are set up on line 29. Yep, go ahead.
No, I was going to say line 29 and line 30, right? Like if you see like on the line 30, like is calling the one
set
function
purpose
of the contract, like the set purpose.
Yep.
So we can call like the same instead of set purpose, we can call transfer ownership and pasting the front-end address that we have.
Yep. So this is our deploy script. This happens when we run a yarn deploy. On line 20, it does the deployment. And then once you have the contract deployed, it's going to do some extra stuff. And we can see on line 29, it loads the contract up. So it connects to that deployed contract. So I think what we want to do is just uncomment that line 30 there.
Yeah.
And we want to call, instead of calling, and then maybe trash that other stuff for now, or maybe comment that line. Yeah.
So this actually does explain like the ownership pattern.
Oh yeah.
Right?
Oh yeah. It's right there. Oh yeah. Look at that. Look at that.
So,
thank you, whoever put that in there. Let's just uncomment that one then, right? And then get rid of 30.
And we want our address.
Yep. I don't think you want line 36 though.
Yeah.
Yeah. No, you don't need line 36. Just
okay.
Yeah, right in there. There we go. And you need quotes around it when it's not in the smart contract. There we go. And we don't need line 30. We can comment that. And let's just take a second to look at that. So on line 29, we load up our connection to our deployed contract. And then on line 34, we call transfer ownership to our front end address. And all of this stuff is being done by that deployer address. So basically the F39 guy deploys the contract and then makes a second transaction on it, setting us as the owner. Is that
Like,
the right way to explain it?
I think so, yeah. And another option, like if we wanted to do only in one transaction, like we could have our front-end address into the constructor, into the arguments, and then calling the transfer ownership from the contracts. Because right now we are calling like from the deployer account is calling like the transfer ownership, but the deployer account could deploy the contract, and then in the constructor function, there we could call transfer ownership. It will be like the same effect, but in one transaction, right?
Let's try it this way, and then let's go try that real quick. It wouldn't be hard, and we'd be changing our own constructor, not the inherited constructor. That's where we'd get it. Why it would be easier. Let's try it this way first, just real quick. Let's make sure it deploys, and let's make sure we're the owner. Uh-oh, what did we do wrong? Unexpected error. Your contract is not defined. Okay, I think it's a capital Y. Every once in a while, yeah, see in line 29, it uses a capital Y, and then 34, it uses a lowercase. Yeah. So whoever helped us out almost got it right. And let's see, are we the owner? Sure enough, F6F, that's us.
Yes.
All right. Okay. So what you
I
were
guess
saying,
that you can call like the create function.
Yeah, make sure we can call create real quick.
Yes.
Yep.
Yes, let's create.
108. Yeah, I don't know why 108.
That's
That's our number. That is our
I
number today. The price of Ethereum next week. Okay, 108. some dark humor from developers. We shouldn't even be talking about price, should we? Okay, so our balance, you check the balance of the contract there. There you go.
Yes.
There we go. 108. Awesome. Okay. So what Carlos was saying is this is actually more expensive because we do the deployment, then we do a second transaction, and that second transaction has some overhead. If we do that all in the same transaction, it's going to actually cost less. So if we let's go back to our deploy script and just comment out that thing. Yep. Let's just comment out that. And you technically could comment out 29 if you wanted to too, but it doesn't matter. Knowing this, if we hit save and we hit deploy, let's do that. Let's save and deploy, and let's see that sure enough, it should be back to F39 as the owner is now F39. Okay, now let's go to the constructor of our contract, the one that inherits their contract. And let's go look at our constructor. Okay, in our constructor, what do we need to call here? We want to call transfer ownership, right?
Yes, like maybe the best way would be to have like a parameter in the constructor, right? So we can like send our address, right? Like the address where we want to send. Like
let's just paste it in.
Okay.
You totally should just have like an address in the thing, but let's just paste it in like we were. I think it's just transfer ownership, right? Do we need to grab? Yeah, you could do that. Kind of. We're gonna paste some JavaScript into our Solidity. It'll work though. I think we just need to call transfer ownership though. You can delete everything before the period, I think, and including the period, right?
Like you can also use like super, right? Like super dot.
Is it super dot transfer ownership? Is that what we need to do?
I think you don't need to do that. I think.
Let's try. Let's see what happens here. Yeah.
I usually do that because it's like more explicit, right? Like you are calling like the parent contract, right? Yeah.
Let's see if this even works. And see, you don't have to be a gigabrain to figure this out. You just paste it in and find out if it works. F around and find out. That's what Scaffold-Eth is all about.
Yep.
And we're the owner again. It worked. Yep. Let's try super dot transfer. Just while we're here and we're talking about it, let's see if it changes anything. Ooh, X cap super. Yeah. Ooh, oh, it likes it. It likes it. It's okay. Totally worked, right? Totally worked exactly the same. But you're saying this is a little more explicit, and it's showing that like we're inheriting something and we're talking to the parent when we call that. Awesome. And we saved ourselves 21,000 gas by putting it all into the same thing, and probably a little bit of like complication, like a little less of a headache. Okay. Inheritance. Let's see. I have on Speedrun Ethereum, I have mapping, structs, modifiers, events, inheritance, sending ETH, and payback functions. So basically we're kind of like at the point where maybe we could show a little contract to contract interaction here. And I can set that up over on my end. I could share my screen again. Anything else from here that we want to cover, or anything you were thinking of, Carlos, that would be good to show off, or have we covered it pretty well?
Like maybe the receive on the fallback functions. I'm not sure if we want to cover those.
I'll do that. How about I do that on my side too? I'll do that over here too.
Like trying to send like money to a contract without the receive function and see what happens.
Yeah.
Right.
Yep. That sounds great. Okay. Let me get us back to. Let me share my screen. Let me get us back to hopefully like the starting Scaffold-Eth contract. Oh boy. Oh boy. Okay, back it up, back it up, back it up, back it up. Should be right there. Okay, now we have our stock Scaffold-Eth contract. I can deploy that. We have our front end here. We've got our units, we've got our primitives, we've got Solidity by example. All right. Okay, so what we want to learn about, right, is receive, R-A-C-E-I-E-V-E. Those French don't know how to spell. E-I-V-E. No, it's the American that doesn't know how to spell.
Maybe like search for send.
Fallback, maybe.
The send. I think send. Oh, send either.
Send.
Yeah, like I think that is the one.
Yeah, this is how to send ether out of the contract, which we definitely should show.
But I think it shows in there,
it's
like in the other one, like in the send.
It's in this one.
Yes.
Yep. Okay. It's weird that it's there.
Yeah.
Yeah, it's here, right? Okay, let's just experiment with it, right? Again, like you don't have to be a gigabrain. You don't have to have all this figured out. You can basically just get Scaffold-Eth up and you can tinker around with it. You could try it, right? I'm going to trash this stuff and I'm going to trash this and I'm going to comment this out. So I'm going to have nothing in here but a constructor. This is just got a blank contract. Actually, we probably need some kind of here, let's do this. Let's have it. That's not very fun. Does this even do anything? Yes. Okay. So let's this or hello. I'm just setting something up so it shows up in our contract. Hello world. There we go. Very, very simple contract. We're storing the string world. This should get deployed. Okay, here is our dummy contract, right? Nothing is happening here. What I'm going to do is I'm going to copy this address. I'm going to open up my wallet and I'm going to try to send $100 to our contract. I'm going to send it directly to the address of the contract. I'm not calling some payable function. I'm sending it directly. Blomp, blomp. It says there's no fallback or receive function. So just like when we had to make that function payable, right? Remember when we had to add that payable keyword? It's safety, right? We don't want a function to take in money when the developer doesn't want money to flow in. Same thing here. You have to explicitly say, I want this smart contract to receive funds. And once you set that receive function and you deploy it, then your contract will be able to receive funds. And not until you add that will that happen. Okay, and let's try that one more time. So now I have a new contract. Grab that address. Grab the wallet. Let's try sending $100 this time. And ta-da, $100 sends in, right? So just by adding that receive function. All right, I'm going to do one other thing. I'm going to say, let's make this a unit 256 counter and we'll set it. It'll start out equal to 0, right? And then anytime anybody, look at this, anytime anybody sends some money in, we'll increment the counter. Very weird. Very weird, but that's what we're doing. We're just trying stuff out. We're learning stuff. We're seeing what we can do. All right, now we have this new contract. And anytime I YOLO funds to that address, our counter should update. Very nice. So let's send another $100. And there we go. Okay, I don't know why, but anytime you send some money in here, and this is really nice user experience, right? If you had some contract here that has some complicated investment strategy, and there's some deposit function that someone needs to call to send in money, right? And that deposit function is probably public payable. A lot of times you'd like your user to just send the money in. So what we do is let's set this up. Console.log. This would be msg.sender. deposited. Oh yeah, good spelling. Deposited, and then some message dot value. Okay, so we could call the deposit function directly, but what we're going to do is anytime it receives funds, it just is going to redirect those funds to the deposit function. Now let's try this out. I probably did something wrong here, or maybe it's not going to let me do this. Totally did. Totally awesome. Okay, so technically I could just deposit, 0.5 ether in there, right? And that's going to, oh, our counter's not doing anything. Doesn't need to. And I'm able to call deposit. But what I wanted to show here is I can also deposit funds by just sending money to the contract. I can just send $100 to this, just like anyone can open up their wallet. Maybe this is even at an ENS address, like Austin's Great Funds.eth, right? If you want to deposit into Austin's Great Funds, you can just send to Austin's Great Funds.eth, send $100, and it's automatically going to call that deposit function. And we see that so-and-so deposited that $100, whatever that is, right? So we can see that over in the contract. Okay, so we've done payable functions, fallback. Yeah, go ahead, please fill it in here. What are we missing?
Maybe it could be nice, like not, since we have a bit more time, to show like the withdraw function as well. So you have money in the contract, but no way out right now. So
yeah,
it'd be a nice time to.
So public. And who are we going to let withdraw? Should we let anybody withdraw? For now, let's do it. So we'll do msg.sender call. No, let's just do transfer, right? We're going to go with the oldest trick in the book here. We're just going to do a transfer, oldest trick in the book. This is weird. Okay, and here we go. We need the address this dot balance. A weird line of code there. I think this even still needs to be payable. I think it's going to complain that that's not payable, but let's see if this works. Basically letting anyone get in here and call withdraw and take the money. Yeah, it's going to say it needs to be payable. A lot of little tricks you have to learn to get this quite right here. Okay, there we go. Now let's try saving that and deploying and see what happens. Nice, nice. Okay, and so now anybody can go ahead and deposit half an ETH, and then anyone can call that withdraw function and withdraw that ETH, right? Okay, so we probably want some modifier there, making sure it's the owner, but I'm just going to build my own. Require that message.sender equals this dude or not the owner. So normally I would just inherit. Oh man, it's right here. Why don't I just inherit it? We were just talking about it, right? Is ownable. And instead of doing this, we just say only owner. And in this case, we would need to also transfer the ownership to our front end guy. Oops. How's that? Is it going to compile? I'm like 20% confident.
80%.
There we go. There we go. Same thing, but now we have a nice like ownership pattern here. We see the renounce ownership and transfer ownership set up. And if we deposit some funds by just sending some money in, let's send in $100. It should go. It should trigger the deposit. And now only we should be able to withdraw, right? Only the owner. And we were able to withdraw. Awesome. There we go. Now we've got the withdraw pattern. Oh yeah. This is the last little bit here, right? So that transfer, if you are transferring to another contract that has a receive function that does some stuff inside of that receive function, it's going to cost gas. So this transfer isn't the right way to do it. You want to go to the sending ether and you want to do this, right? Just kind of a little like pain in the butt, but you just kind of have to learn this stuff. So we'll say message.sender.call and the value will be that, right? And technically we can get rid of this to make sure we don't get that warning, and we can go ahead and require that it works. Totally copy and pasting, but let's see if this works. Does this need to be payable? Doesn't look like it. Looks like it's happy. Yep. So even though this line looks a little bit more obvious, this is the right way to do it because of gas limits. And let's go double check that. We can YOLO into the contract. Oops, I didn't go to the right address there. YOLO into the contract and make sure the money goes in. Got $100 and then make sure we can withdraw and the money comes out. Okay, done. We got it, right? We were able to write our own there, show the transfer, show the ownable, show the deposit, show the withdraw. I feel like now we do contract to contract, right? Is that, are we about at that point? Have we filled in anything else? Anything I'm missing here? Any insights? Should we go for it? Time for a second contract?
Yes, because you say like
Okay.
on line 22, right? Like you said that can be a problem if you send money to a contract, right? But we always, I mean, for us, like msg.sender is always been one of us, right? One of these accounts.
Externally owned account. Yep.
Yes. So what happens? I mean, how can it be possible that a contract to be the message sender?
We're about to find out, right?
Yes.
Okay, so what do we call it? So this contract is kind of like a bank where people can deposit and withdraw. Really what we could do is we could keep track of some mapping. Ooh, how about we do that? How about we have a mapping? Whoops, I'd like that. Bring that back. From some address to some unit 256, and this is your public balance, right? And there's not going to be any ownership. The bank is ownerless. I think that's a really neat thing to have, right? So let's see. So we're going to have this. We'll have no ownership. We'll actually not even have a constructor. We'll have a deposit, a withdraw. The deposit is going to balance of msg.sender plus equals the message.value. And the withdraw will do, ooh, here's re-entrancy. Let's just set it up so you can re-enter into it. We'll talk about that later. We will first send you your balance. And then we will reset your balance. Okay, we just made a bank, right? It allows you to deposit money. It keeps track of your money. Oh no, minus equal. No, it just sets to 0 because it sends you the balance. Okay, let's make sure this works real quick. Let's make sure our little bank works. And then we'll create another contract that talks to the bank, basically. Okay, so here's our bank contract. Let's have 2 different players that are going to play on the bank contract. We're going to have green guy and purple guy. Grab some money for purple guy. Okay, so hopefully purple guy has some money. Let's get some more money for purple guy. Let's go. Okay, so purple guy wants to deposit $20 into the bank. They could call the deposit function, or they could just send money straight to it. So we're going to send $20 into the bank from purple guy. There we go. So now the bank holds $20. And if we check the balance, we should see that this guy's balance, oh, that's kind of weird, but yeah, that's 0.1. Be nice if that showed it in USD. Okay, now let's have green guy also deposit some funds. Green guy will use, let's see, how much do we have? Oh, wow, let's deposit an entire ETH. Kaboom. Now we'll see that the contract value goes way up, right? Now there's 1,200 and some in there. And our balances are separate, right? This guy has a balance of 0.1. This guy has a balance of 1. And if they withdraw, they should only be able to get their money back, right? So if I call withdraw from this guy, the balance of the contract goes all the way back to 20. And my balance goes down to 0, right? So simple contract. We're keeping track of a mapping. We're letting people deposit and withdraw. We're making sure no one can deposit or can withdraw from other people's funds. Very, very simple contract, but basically just lets people deposit and withdraw money, and we keep track of everybody's balance. Make sense there? Did I miss anything there? Does that look pretty good? Okay, here we go. So I'm going to call that bank.sol. Okay, so we've got bank.sol. Okay, and then we've got your contract.sol that will do something different, but let's just set it up to be, I don't even know. Maybe we just set it up as ownable or something. I don't know. Let's see, public. I don't even know what to do with this contract yet. Public, let's just make it a string. I don't even know. String public purpose. We always do this, right? This guy is hello world. Okay, simple contract. Now we have two contracts. We need to deploy both of them, right? First, we probably will deploy our bank, and then second, we'll deploy our your contract. So I'm going to head to the deployment. Now I think technically, usually you duplicate this for a second contract. I think I'm going to go ahead and do that. So we'll deploy your contract, and our zero will be deploy. I'm going to rename it. We're going to deploy the bank. Okay, and this will deploy bank. Man, I hope I'm doing this right. Let's see. And this will export bank. So hopefully we should deploy the bank as the first contract, and then we should deploy your contract as a second piece. Let's see what happens. Let's just try it out. Let's just try it out. See if I'm missing something here.
I think you will need to add to the React application, like the contract,
Yep.
you know, like
Yep. Something here, this right here. It's not finding your contract.
Yep.
Good to go. Okay, so now we should have both the bank and your contract. Okay, we got to go edit the front end now, right? We're going to go here. I'm going to look for that contract component. There's a nice contract React component. Isn't this sweet? You just have this nice contract here, and I'm going to bring the bank in right below it.
So maybe it would be nice to like show the front end like before editing as well, like what pops up.
Oh, okay. Yep. It was just showing your contract. Basically, without the bank there, it just showed your contract with the hello world. And then I'm just going to paste in the bank. So we have a second contract there. There we go. So now we have two contracts we're talking to. There's our bank that we created that lets anybody YOLO some funds in here. Like I have 0 for my balance. I deposit 0.1. And now if I go check my balance, I've got 0.1 deposited. The bank is holding that. I can withdraw, right? So as an externally owned account, I can invest in my bank or I can lock money into my bank. But what we want to do is have this contract be talking to the bank, right? And that's when it's going to get tricky. Anything I'm not covering enough here? I feel like maybe there's some any questions or thoughts here before we keep going? Okay. So our contract needs to set up basically an interface to talk to the bank contract, right? The best way to show that at first might be to show our balance, but it's not going to be set to anything. So I feel like let's just set up our constructor. Okay. And in our constructor, we're going to have an address. Actually, let's not even do that. Let's just have a connect to contract, something like this. This is going to be really weird. It's not exactly how you do this, but I want to call some connect to contract. I want to set up an interface to it. So what we need to do is we need to have the interface up here, right? We need to have an interface like this. Here's what an interface looks like, where it doesn't have the actual functions. It just has something that looks like this. Is that about right? Is that what an interface looks like?
Yeah, maybe
And
not
so,
sure if you need like some semicolons at the end of the.
Like this?
I think so, yeah.
Got to have Carlos. Carlos got to have some semicolons. Oh no, didn't like that.
Maybe that remove the yeah.
DK. Oh, they need to be virtual, maybe. I don't know. I'm going to go back to just it compiled. I'm going to go back to this. Let's make sure this compiles. Uh-oh. What did I do wrong there? Duplicate output destination bank.json.
Oh yeah, you like
Because it's compiling this, isn't it?
Yeah, maybe. Yeah, like you need to put like the interface word instead of like contract. On line 8, that needs to be interface, not contract. Yeah.
I don't think I've ever done it like that before. And then maybe I need those semicolons.
Yeah, maybe. And I think maybe they need to be external or something like that.
Okay. Yeah, but here's what we can do. Instead of bringing in the interface, which is really nice to have the interface there, we can just import it, right? We can say import./bank.
Yeah.
And that will do the same thing. Let's see if this works. We're doing it like 10 different ways. Okay, that actually worked. Okay, so it does deploy the bank, then it deploys your contract. We have the bank imported in, and what that allows us to do is we create some kind of bank. We'll just call this bank contract, right? And then what we can do is say bank contract equals, and we want to, now if we say new bank, it's actually going to deploy a bank contract, right? So this is a factory. And so when you deploy your contract, it's going to deploy a new bank contract. But instead, we're just going to say bank. We're not going to say new. And we're going to put in an address here, which will come in from here. Bank address. Okay. So now really, really strange stuff, but this is how you set up one contract to talk to another contract. You create an instantiation of the bank, and then you pass in a bank address, and then it's going to create a connection to that second contract. And we can talk to this new bank contract in a second. By doing this, we need to edit our deploy and make sure we pass in our bank address to here. Ooh, so we're going to have to do like a, get this, right? We're going to say bank contract equals bank, and then we'll do bank contract dot address. Am I doing this right?
Yeah.
Let's see what happens. 20% sure. Yeah. Payable address here. Maybe we just say this is a payable, or maybe we type def it to payable. Let's see. If this works, we're going with it. If not, well, there we go. Okay, cool, cool, cool. So what is happening here? First, we're deploying our bank. Then we're getting the address of the bank, and we're deploying our your contract with the address of the bank passed in. So then what we should see here, ooh, let's make this public, right? Ooh, can you do that? What happens if I do this? Hopefully it'll be an address. I don't know if it's going to let us do this. What would be nice is if it showed it. It does. Okay, that's nice. Pretty. I like that a lot. I like that a lot. Okay, so let's see this again. We'll deploy our bank. We'll get a new bank contract. Then we'll deploy our your contract, and you can see that the bank is there, right? Notice this is the same as this. So our contract is tracking where the bank is, and it knows how to get our address. So then let's just go over to the bank. What can we do? We can call balance. We can call withdraw deposit. So let's my balance, right? And what that's going to do is it's going to return bank contract dot balance of address this. Super weird. And this needs to be a view function that returns a UINT 256. And let's see if that works. Basically, hopefully we can call my balance on your contract, and it will get us our balance at the bank. Okay, it's 0. Okay, cool, cool, cool. Then we need some other function.
Like deposit maybe?
Oh. Yeah, go ahead.
No, I was going to say like maybe like a deposit function, so we can send like some funds from our account to this contract.
Should we make it payable?
Yes, and then this contract will send that money to the bank.
Okay, right? Let's do it in 2 different steps though.
Okay.
Let's set it up. So, okay. Yeah. So right now, when we deploy this thing, we're not able to send money into our your contract, right? Because we forgot about this receive function. So let's set it up so our contract, let's just prove that, right? If I copy your contract and I try to send money to it, it's going to fail saying it doesn't have a receive function. Okay. So let's put a receive. Ooh, that wasn't what I wanted. Let's put a receive function into, oh man, what did I do? Bank.0. What am I doing? What have I done? I want this line of code. Please copy. And I want it pasted right here. Okay, fantastic. And I'm not going to do anything. I'm just going to allow money to flow in, right? So now we can at least send money into our contract. This should get deployed. And if I copy paste it, I should be able to send $100 to it. Yes, okay. Then, so we're going to send money into our contract. And then we want to call another function on our contract that deposits it into the bank, right? So what we'll do here is we'll say bank contract.deposit. And then, ooh, do I do this? There's like a value thing, right? Yeah, so weird.
I'm not sure if you need the parentheses of deposit.
Oh, I don't. Oh, it's called before that. I see what you're saying. You're saying move this like this, I think, right?
Yes, yes.
Yep. One arguments and expected it to be 0. Yep. Super weird there. So I was thinking I needed to use it as an override like you do in ethers, but when you're in Solidity, you do that weird thing where you have the overrides kind of before that, right? Okay. Now we should be set up. We're ready to first, let's put some money into our contract, right? So let's send 1 ETH into our middleware contract. 1 ETH, go. Okay, so now this guy should be holding value. Yep, so now he's holding 1,200. Okay, then we want to call deposit. Let's deposit like half of it into the contract, right? So this should hopefully, oh wow, it even updated our balance and everything already. So now we see $600 in the bank and $600 in our contract, right? So half of the ETH still lives in our contract. The other half has been deposited. In fact, I could call that again, right? 0.5, deposit the second one, right? There we go. So now we're doing contract to contract interaction, right? And
like maybe you can, yep. I'm sorry. No, I was going to say that maybe you can check the balance on the bank contract with the with your contract address, right?
So we grab this address and we go to the balance and we check it and it's 1, right? Yep. Which is actually the same thing this guy is calling too. The key here is the msg.sender. Who is the msg.sender, right? That's what we're really trying to get figured out. When someone calls deposit, it increments the balance of the msg.sender. So when your contract calls deposit, who is the msg.sender, right? Let's put a console log in here and really see this, right? Console log. And we're going to say msg.sender deposit and then message.value. Okay. Mm-hmm. And the other, I want to put tx.origin in there eventually, but let's see this. Yeah, we want to do that too. But let's see that this happens. Okay, so we have a fresh contract. We need to send money. Oh, this is why we want to do it all as one step, because it's a lot to get set up. But I'm going to send in 0.5. Okay. So now we've got the $600 in our contract. And then if we do the deposit of 0.5, actually let's just do 0.1 and we hit send. What we're looking for is the console log over there, right? Okay, 2E2. So the message.sender is 2E2. It's not us. It's not our 765. Even though we're triggering the contract, the message.sender is this guy, right? Of course it is. That makes sense, right? So it's like we have the externally owned account, right? And then we have your contract, which is the middleware, and then we have the bank. And we're telling our contract to invest in the bank. So the msg.sender is our contract. And the last thing I want to add here, let's see, a tx.origin is another units, right? If we look at tx.origin, it's the sender of the transaction. It's always the person that signed the transaction. So almost always, when it's an externally owned account talking to a smart contract, the tx origin and the msg.sender are the same address. They're that originating address, right? But when we're calling a middleware contract and that middleware is talking to the other contract, then that gets a little blurry. The tx.origin is always going to be us, but the msg.sender will be that middleware contract. And we should see that here. If we run, let's go ahead and deploy this last one. I don't know if it's going to let me do that with the console log. It did. Very cool. Thank you, Hard Hat. Okay, let's send in $100. Let's do this again, right? So we send in, we go to our contract and we send in what, $1,000, fine. And then we go ahead and deposit 0.01 or something like that. And we hit send. There, let's go look at that console log. Okay, so DC1, which is our middleware contract, is the msg.sender. But the tx.origin is our account. Whoops. So see that the 765 is the tx.origin. So like, just like really, let's hammer that home. If I go to eth.build, I can draw something that'll show this off really, really simply. And I think it's probably the way to go here. If I select all this stuff and delete it, basically give me this, right? So here is our EOA. EOA, okay. And then it's talking to a middleware contract, right? Here is your contract. Okay. And then it's talking to a third contract. We'll make that green guy, right? And this is the bank. Okay. And so when we see the transaction here, there's the msg.sender. So msg.sender looks like a child wrote it. Is the orange guy, right? The msg.sender is the orange guy, but the tx.origin is the blue guy. Okay, super childish. We had to draw it in crayons to make it obvious, but that should make sense. When an EOA is talking directly to the contract, it's both the msg.sender and the tx.origin. But when an EOA talks to a middleware contract, the msg.sender, in terms of what the bank sees, is that middleware contract. Hopefully that explains it all. Hopefully that shows it off. We can hint at something here. Carlos, you brought this up when we were playing around with the Wolf game. There was a specific piece of that contract that wanted to make sure that only externally owned accounts could access it. So if you wanted to make your you wanted to make some function like this deposit, and you wanted to say only externally owned accounts can do it. If you try to have a middleware contract attacking it, we don't want to allow that. What you can do is require that the tx origin equals the message sender, right? And we say only EOAs or something like that, right? This line of code basically breaks if you try to hit it from a middleware contract. This says that the only person that can talk to this function has to be an externally owned account, and that tx origin has to be equal to your message.sender.
Maybe
And the other
try,
way
right?
around. What's that?
I was going to say that maybe we can try with I mean, you can deploy this and try
Let's
see what
try
happens.
it. Yep. That's the best way to find out. Let's just deploy it and see. So now we can totally deposit some funds into this contract. Let's close up eth.build. We can deposit some funds in here as our externally owned account, right? This guy should have no problem talking to the bank. He wants to deposit 0.05. He sends. There we go. Money goes in, right? But if we put some funds into this contract, and then we try to do the same deposit, only EOAs, right? It doesn't let us go through our contract and deposit into our bank, right? And when we built that smart contract game, I wanted only contracts talking to it, right? So in this case, I required that the tx.origin does not equal the msg.sender. And this is only contracts, right? Another weird one you could do. If you wanted one smart contract to never accept a transaction from an EOA, you have to use some middleware contract. You could set up the require like that. Super weird though. let's pull that out of there. Set it up. Okay, I think we've gone through a lot of stuff here. We've kind of we showed you at home how you can pull up Scaffold-Eth, get it installed, immediately start like writing some Solidity and start tinkering with it and learn. We've talked about how the wallets work, how you use a burner wallet at first, but you can connect in another wallet. We've talked about, you know, a bunch of syntax and how to get started with, you know, primitives and data types and globals and just like going through this. Oh, we left re-entrancy, right? We've got a bug right here. Maybe we should end with this because it really does kind of highlight all of the stuff that happens with all the weird things and how to get in here. And by the way, when you go to Solidity by example, after you learn all of these different things, which if you're a programmer, you'll figure it out quick, except for maybe delegate call. That's some weird shit. But once you get that stuff, you'll get it figured out pretty quickly. There's a lot of good applications, but down here all the way at the bottom are hacks. And if you really want to understand how Solidity works, once you get the basics of Solidity, you should start looking at the attacks and figure out how this works. Re-entrancy is one that we'll look at here, but learn the attacks. And just to double down on that, there's something called the Ethernaut. Yes. Once, what did I do? Ethernaut challenge. Here we go. Ethernaut.OpenZepplin. Here we go. So once you've kind of got a feel for that, you're able to learn how to tinker with Solidity. You want to start really testing your knowledge. The Ethernaut is a great place to go, and it'll take you through kind of a lot of these different challenges. Okay, here we go. Let's talk about re-entrancy to close it out. It's going to get really weird here, but we have to talk about it. So this withdraw function, what's happening here? We go, let's go ahead and just talk to the bank, right? We don't even need the middleware contract here. Well, we would use the middleware contract to actually attack it, I guess. But let's just do a withdraw as us. So we go to the bank and we deposit some funds. So we are green guy, and green guy wants to deposit 0.1, and he goes here and deposits, and it's fine. And we can check green guy's balance. It's 0.6. And then green guy can call this withdraw function, right? And when we call withdraw, it's just going to transfer our balance to us, right? No big deal. Basically, it works out of the box. This works fine. Now we've got an attack vector here, and it is kind of interesting. What happens here is when we call this withdraw, it's actually making an external call, and it's actually going to send the funds. But let's say we have a middleware contract, just like we have here, and it does something special when it receives funds. This is how we would attack this bank. Is what we would do is we would call withdraw, and when it withdraws to our middleware contract, we would do something else here. We would actually call withdraw again, and we could get into this loop where we're looping, and we call withdraw, it goes to our attacker contract, and then our attacker contract calls withdraw again. And it loops over this, basically sending our balance to us over and over and over again. And it never gets to this line until it runs out of gas. So let's highlight that a little bit better. Let's actually set up our attacker contract to do this. But it's really funny. The solution to this is basically to have a uint 256 temp here, and we set that to our balance. Okay. And then we zero out our balance. Okay. And then we go ahead and send temp here. So this fixes re-entrancy. This re-entrancy bug, millions of dollars have been stolen out of smart contracts because of this re-entrancy bug. And this is the fix. Basically, you do your state updates. You do any internal state updates first. You make sure that balance is 0, and then you do all your external stuff. You make sure that, like, if you call this and it's going to some external thing, they can't re-enter and still have a balance. We see we've zeroed out their balance before they get there. Okay, so let's go ahead and let's leave it attackable. And let's attack it, right? Let's what do we got? We got a little bit of time. We got a little bit of time here. Let's attack it. Okay, so let's make sure all of this compiles and everything is good here first. Awesome. I think I like your deposit, making it payable. It'll just be easier if we take this out and do message.value here. Of course, Carlos was right. I should have listened to him in the first place. Okay, and let's make sure that all works real quick, that we can basically do a deploy by just calling one function, or do a deposit by just calling the one function here. So if we deposit 0.1 ETH, this should go all the way to the second contract. Yep, so it goes all the way in, right? So by depositing into your contract, it immediately takes all of that money and deposits it into the bank. So you shouldn't ever have money here. Even if I like YOLO some funds here, what happens? Okay, that's not going to. Yeah, funds are just going to go in because it's not doing anything here, right? We could technically do this and then it would do the deposit. But we're going to do something special there. So let's not even mess with that. Okay, so we have our attacker contract here. We have the bank here. And now we have to assume that the bank has some extra funds in it, right? There's going to be lots of people depositing. Let's just have some poor second person here who's going to lock their money up in this bank. And it's a bad idea. This bank is going to be, so we got purple guy. Purple guy is not going to be happy about things. Let's give purple guy some funds. Okay. Well, purple guy's happy. He just got $10,000. Okay. So how does this attack work? Basically, we're going to deposit some funds in, and there's going to be more funds in the bank, and we're going to want to withdraw those funds, right? So what's going to happen is we're going to have some function called do the attack. Okay. And what it's going to do is it's going to call the withdraw function on the bank contract here. Okay, so we know we need to do a withdraw. And let's see. So this will be bank contract. We're going to have to like check gas and stuff. It's been a while since I actually wrote this in Solidity. Like it's a lot easier to explain it. Like, yeah, you have a middle contract, it attacks it. To actually write it up, this is going to be a little bit more time consuming, but let's figure it out. So we want to call withdraw on, and let's just do that first. Let's just make sure this works. Let's do this one step at a time and make sure the code all works. Okay, so now we should have our starting contract. Everything is empty. Let's put in 0.1. We do the deposit, $120 show up there. My balance is 0.1, and do the attack isn't going to attack anything right now. It's just going to withdraw our funds back, right? And then they land back in the contract for some reason, but whatever. Oh, there's no withdraw function. So actually they're locked there, which isn't great. Maybe let's build that real quick. Nah, don't worry about it. We're in a hurry here. You would definitely have, we could even do something like pay the msg.sender. We do what? Payable msg.sender.transfer address this dot balance, whatever. So whenever you do the attack, it withdraws and then sends the balance. Let's see if this works. I want the money to go all the way back to us just to see. You know what? It looks better when it ends in the contract. This is what you would do. I'm like rambling here. This is what you would do, but let's just make sure this works. 0.1. Go ahead and deposit that in. And then what I want to do is just do the attack and make sure the money comes all the way out and lands back here. And it does. Okay, so there's no money left in the contract. Actually, let's leave that out for now. Okay, here we go. We want to call withdraw. And when we call withdraw on the bank is going to immediately send us our balance. And what happens when they send us our balance? It's going to call this receive function, right? Ooh, interesting. Okay, so let's see here. What if we did just one more of these? Okay, so we'll keep some state variable called uint 256 times let's just say attacked, and we'll say let's just say bool. Here we go. We're just going to do this. Bool attacked equals false, and we're going to say if it hasn't attacked yet, go ahead and set attack to true and call withdraw one more time. Okay, so basically when we withdraw, we're just going to withdraw one more time also. So we should actually withdraw twice for the price of one. We should be able to pull some money out. Kind of weird. We can talk through this some more. Let's see if this works. And then we can talk through it some more. Okay, cool. So now we have our attacker contract. We have our bank. What we need is some extra funds in our bank. So we're going to have attacker guy. We're going to have just this guy who's going to have a bad time here. They're going to put in well, 0.5 ETH. Okay. There we go. And so we could check their balance. Basically, they have 0.5 ETH in the contract, and if they want, they could withdraw. Okay, so poor purple guy has invested in the bank, and they think everything is safe. They looked at the code; it looks good, right? They're like, oh, this bank looks good. It does a send, it sets it to 0. Fine, I'm good. I'm invested. I'm in. I got value locked in here. Okay, so we come along. What we're going to do is we're going to deposit 0.5. Okay. And that's going to go all the way in. So now the contract has one whole ETH in it. It has our half and it has their half. Now, when we do the attack, okay, it's going to call withdraw. And when we call withdraw, the bank is going to send us our half ETH. And then when our contract receives the half ETH, attack is going to be false. So it's going to get into here. It's going to set attack to true, and it's going to call withdraw again. Back into the bank. The bank is going to send us another 0.5 ETH, and then it'll land here. It won't do anything. It'll come back here and set our balance to 0. And if this works, we're going to run away with purple guy's half ETH. If this works, let's find out. Here we go. Let's do the attack. Oh, what just happened? Let's see what, the bank is empty and our contract now has the whole ETH in it, right? And this guy over here, if he checks his balance, he still has 0.5. If he looks, right? He says, hey, what's my balance? The bank will say, you still have 0.5. And he's like, okay, let's withdraw. Wah, wah, wah. There's no money left in the contract, right? So even though this guy thinks his balance still is 0.5, the bank is empty, right? Does that sort of show off what happens here? I think what you would do is you would want to drain the contract, right? You wouldn't want to just pull twice your amount out. You'd want to run this thing until you're out of gas. So you do something like, if the contract still has a balance and I still have some gas left, I think there's like a gas left you could ask, like, if I still have gas left and the contract still has money in it, keep attacking. And keep going through this loop until either we run out of gas or the contract runs out of money, and then you drop out of the loop. Hopefully that kind of explains it. I mean, it's a pretty complicated attack, but it's, you know, pretty straightforward. Any questions or insight here to add to this? Does that cover it?
Yeah, I think so. I mean, it was great to show like the demonstration. I just wanted to say one thing, and ask that when you write like some Solidity, some method, like just keep in mind that there are not only users or external own account users like are interacting with your contract. So also other contracts can interact with your contract. So just like keeping that in mind when you are writing like some Solidity, because things like this can happen, right?
Awesome. I'm just going to go ++. And I'll say if attacked is less than 3 or something like that, or 4. Let's just like loop on it a few more times, right? Redeploy this and let's see it go again. Ooh, what did I do wrong? So this time it'll just loop like 3 or 4 times. We'll put some extra money in the contract. So this time maybe we'll only deposit 0.1. Okay, so let's see. So again, to set it up, this guy needs to deposit some funds. What's he have left? Yes, yeah. So let's deposit a whole ETH. Okay, and then to attack that, we're just going to deposit like 0.1, right? So we've deposited 0.1. Now when we do the attack, it's going to pull out like 0.4 or something, right? We're going to end up with 4x the money. Yeah, 0.5, right? So we pulled out a whole bunch more. We looped a bunch more times. Yep. But yeah, I think that the trick here is just knowing that when you write your contract like this is bad. You want to do something like temp here. Oh yeah, let's try to attack it now, right? Let's go back to. Oh, wait. Bool attacked, not attacked, attacked equals true, withdraw. Okay, there we go. Let's deploy the whole thing again. Now it should fail, right? It's going to tell us that we don't have a balance or something like that, and the attack will fail. But it's worth trying just to show that it works or doesn't work. And then I think we can call it. I think this was a good day of Solidity tinkering and a good day of like getting your Scaffold-Eth set up. Okay, let's see. We need to deposit 1 ETH. There we go. Then over here, we deposit 0.1. Okay, now when we do the attack, oh wait, it worked. Wait, so what did it do? It didn't withdraw. It only withdrew the 0.1. Oh, it called withdraw again, and our balance is 0, right? So we could set a require statement here to say your balance has to be greater than 0 to enter here, but whatever. We're letting them withdraw 0, so it doesn't matter. The point here is that this person's balance is still in the bank and someone wasn't able to steal it, right? We did it. We learned more Solidity. We helped you at home set up Scaffold-Eth. Next week is going to be all Scaffold-Eth. We're going to speed run Ethereum. We're going to assume that you've got the syntax down, you know how to tinker with smart contracts, and we're going to dive into what you can actually build with smart contracts and why this expensive decentralized substrate is so powerful, and what things you would deploy to this and what things you wouldn't deploy to it. Awesome stuff. Happy 10th day. Day 5 of week 2 is done. Thank you all for being here. Awesome. All right. See you guys.
Everyone.
See you. Bye.